Hi, okay, let's move to the observability and monitoring part of this fintech system design. Here I have also written my architecture diagram further with the proper coloring so that it will be easy for us to properly categorize and use and understand the usage of the different tools over here. So first of all, for the observability, we have three different tools here. One is the logs, and the other are metrics, and traces. They look like the same, but there is a minor difference between all of these, and it is in the market. It is better that we use different tools for these three, for collecting logs, and then for properly formatting them, extracting them, and then at the visualization level, what we do normally that we can use one centralized dashboard to visualize all of these three for proper helping for proper disaster recovery with minimal recovery time objective. For minimal recovery time objective, it is best that we use the best tools like we have a concept of horses for courses. We have different tools present in the market, but there is not any centralized one for all tools. So it is better that because the system is very critical with many financial tech related data present, very sensitive data present. So it's better that we use the best visualization tools, best extraction tools for logs, metrics, and traces. So yeah, that is the reason that I have chosen some best tools here. First of all, let's start with the log collector. For that, what will happen normally is that this will be an async operation. All our services like auth, accounts, ledger, and notifications, they will be they doing their normal flow, and at the same time, they will be creating logs locally in their local systems, like in their file system or maybe in their local database services. But the best practice here is that to use their local file systems to keep on creating logs. And then we will have a service like log collector service. This service, or we can use if we are using the ELK stack, it is a very famous open source stack where Elasticsearch, E stands for Elasticsearch, L stands for Logstash, and K stands for Kibana. So here the L Logstash can also do this part of log collector. It depends on us. It depends on our use case and on our mood that what tool we are going to use. This log collector service will be uh, collecting logs from all of these backend microservices from their file systems. Uh, these logs can be in some text format, in XML format, in JSON format, and then it will be the responsibility of this log collector to properly collect them without any data missing, and then format them properly into one centralized format, which we will be using. And then what we can do, we will be using the open source search time series database. This opens this log collector. After properly formatting all of those logs, we'll move those logs to the open source time series database for permanent storage purposes. And after those, if we have then the purpose of using the open source search time series database is also that it is a document-based database with the it will do the proper indexing on all of those logs, and then it will properly help us to do a searching on those logs very efficiently in a very minimal time, in a very minimal latency. So that is the reason of using the open source time series database. And then to properly visualizing those logs, we can use the Grafana dashboard. Grafana dashboard is a very famous tool for properly visualizing our data in a different formats. It has different options present, like graph or whatever the tool we want to use for properly visualizing our logs. So yeah, that with the combination of the log collector and the open search time series database, and then using the Grafana dashboard for properly visualizing our logs, we can properly see all of the different logs for all of our microservices here. And then logs can be of different types. We have an error types here, the warning, info, audit, relevant messages, and then users can properly, and all of the relevant stakeholders can properly see all of the relevant logs here in the Grafana dashboard. Okay, and now let's move to the metrics part. Metrics part is a little bit different. We have an open source tool present, Prometheus. It is a very famous tool for properly getting the metrics. Metrics are a little bit different than logs. In case of metrics, all of these backend microservices will be exposing one API, REST API. It will be that will be like the backend microservice name URL, and then appending it with front slash metrics. So what will Prometheus will be doing? It will be scrapping. It will be hitting that metrics endpoint, and then it will be getting all of the metrics for all of these backend microservices. And then it will be the responsibility of Prometheus to properly formatting, extracting, and getting all of those metrics. We have a different types of metrics present here. Like each of these backend microservices will be properly returning results of request count for some specific count, proper latency, P95, P99 latency for each of these backend microservices. What is the normal error rate in some specific time, if it is going above the threshold or not, or how many database connection this service is having right now with our primary database server, database connection, pool size, different metrics. These are some of the few which I have mentioned here. So in that metrics endpoint, that specific backend microservice will be returning all of these, and then the Prometheus will be properly scraping that metrics endpoint. And then Prometheus will also be attached to we can use the Prometheus native alert manager, or we can use some third-party tool like PagerDuty or Slack Connect. So if there are any some thresholds which are being not being followed, like let's say our latency is going above our threshold, in that case Prometheus will automatically send some alert notifications to all of our relevant stakeholders. And same goes with the Prometheus will also be attached to our Grafana dashboard, so for properly visualizing our logs and metrics as well. And then for OpenTelemetry, or specifically for traces, we have this green color present here. OpenTelemetry is an open source tool specifically for traces. It is a standard being used in the market. So there's a minor difference between metrics and logs. So logs are specifically related to that one microservice. But in case of traces, we need to properly track each request from start to the end until that request is being finished. It is being inserted into the database. Like one request starts from the client, the user sends the request to transfer the money. It will go to through the API gateway, through the global load balancer, and through the auth service from the Redis cluster, and then back to the account service. It will go through different microservices. Maybe it will hit Redis cluster, Archie Kafka cluster at the same time. It will go to our primary SDB server, maybe to the secondary as well. So, but still that will be one same request. To properly trace that request, we have a standard present in the market, which is called the OpenTelemetry. That part of the request specifically relevant to one service that is called span. Multiple spans aggregate together to become a trace. So to properly trace that request, what we will do, we have an OpenTelemetry SDK present, which we will install, which we will instrument in each of these microservices. Like in the auth accounts, this will be installed in all of these services, and that will properly help us in tracing each of these requests. And then we will have an OpenTelemetry collector present. The responsibility of this collector to properly get all of those requests from our local OpenTelemetry SDKs, which are being installed in all of those services, and then combine them together, aggregate them, format them in one single, so that with the main thing here will be the correlation ID, trace ID for each request, and then OpenTelemetry will collect all of those requests with respect to those trace IDs. And then we have some open source tools present in the market, like Jaeger, Tempo, or Zipkin. These are very famous tools for analytics UI, for properly tracing those and visualizing those requests traces. Yeah, and then as we are using the Grafana dashboard for our visualization, so it's up to us that if we want to use these tools or not, or we can also directly uh, move all of those traces directly to the Grafana dashboard instead, and we can just skip these analytics UI tools. So what my suggestion is will be to first to use both of these at the same time, where we can use these analytics UI tools as well, and then we can also use the Grafana dashboard. Grafana dashboard will be best because if we want to see all of the logs, metrics, and traces at the same in the same view, we can see all of these. So that is the reason I have further connected these analytics UI tools with our Grafana dashboard. So yeah, with the combination of these, and then in the Grafana dashboard, we have different sections present for logs, metrics, and others. And in this Grafana, there is an also option to for properly uh, connect logs, metrics, and traces with each other. And this will help us to properly trace our errors, what are the bottlenecks we are facing in our system, how we can improve them. And this helps in making our system much more reliable, fault tolerant, resilient, and fast. And this will also help us in making our decisions smarter.